Chapter 5, Number 26. Three objects, A, B, and C, have x and y components of velocity that vary with time as shown in the figure. What is the direction of the net force acting on each object as measured from the positive x-axis? All the non-zero slopes have the same magnitude. So if we look at this, we're really going to go through using that the sum of the forces is the mass times the acceleration. So if we know the components of the acceleration, we'll be able to figure out the force on it. So let's look at that. Let's figure out what AX and AY would be for A, B, and C. Alright, well, for object A, the x velocity is constant, so AX is 0. Whereas the y velocity is positive, and although I don't really know the value, I'm just going to call it plus A, plus some value. So plus some number. If we look at B, right, because the acceleration is always the slope of the line. If we look at B, the slopes are the same. They told us that. And so we would get the same in A and Y. And then for C, we have the same magnitude, but the x1 is decreasing. So it's minus A. And in the y direction, it's plus A. So if we sort of just sketch out the vectors, the force for A would be pointing entirely in the y direction. That's the amount. Now, object B has the same y component, but it also has an equal x component, and so the actual thing would look something like that. And object C has the same y component, but it has an x component that is negative and as large, and so we get that. We can do a little further and remember that since the x and y components are equal, this angle is 45, and then that means also this angle is 45, so the total angle would be 135 for angle C.